Hello, everybody. This is Jyoti Mayekar, and today this is the fifth part of Legends of the Physics World. Guess who? He was an Indian physicist who carried out groundbreaking work in the field of light scattering, which earned him 1930 Nobel Prize in Physics. He discovered that when light traverses a transparent material, some of the deflected light changes wavelength. And in 1954, India honored him with its highest civilian award, the Bharat Ratna. In conversation with Mahatma Gandhi in 1945, he said, "If there is a God, we must look for him in the universe. If he is not there, he is not worth looking for. I am being looked upon in various quarters as an atheist, but I am not. The growing discoveries in the science of astronomy and physics seem to be further and further revelations of God. Mahatma ji, religions cannot unite. Science offers the best opportunity for a complete fellowship. All men of science are brothers." Yes, I'm talking about Chandrasekhara Venkata Raman. So, the main discovery of Raman is Raman effect. When light traverses a transparent material, some of the light is deflected, changes in wavelength. This phenomenon is now called Raman scattering, and the effect it is called as Raman effect. Apart from Raman effect, the second important discovery is in the field of musical sound. One of his interests was understanding the physics of musical sounds. He worked out the theory of transverse vibration of both string instruments on the basis of superposition of velocities. He studied the acoustics of various violin and related instruments, including Indian string instruments. Raman also studied the uniqueness of Indian drums. His analysis of the harmonic nature of the sound of tabla and the mridangam were the first scientific studies on Indian percussion, and that is how he used to visit a church a lot so as to understand the acoustics of church. Uh, Raman investigated scattering of light starting in 1919. His first phenomenal discovery was the physics of the blue color of seawater. Once he was on a voyage, during a voyage from England, he contemplated the blue color of the Mediterranean Sea. And actually, there were many theories were put forward by different physicists for the blue color of the sea, and good explanation was given by Rayleigh, and he suggested that it happens because of the scattering phenomenon. Raman was carrying simple optical instrument, a pocket-sized spectroscope and a Nicol prism with him during that voyage. He studied the seawater using that simple pocket spectroscope and Nicol prism. And that time he suggested that the molecular diffraction determines the observed luminosity and in great measure also its color. So the blue color of the sea, it is not because of the scattering phenomenon, it is because of the molecular diffraction. Other discoveries, Raman determined the spin of photons in 1932, which further confirmed the quantum nature of light. Raman and his student Nagendranath provided the correct theoretical explanation for the acousto-optic effect, that is light scattering by sound waves, in series of articles resulting in the celebrated Raman-Nath theory. Modulators and switching systems based on this effect have enabled optical communication components based on laser system. Other investigations carried out by Raman were experimental and theoretical studies on the diffraction of light by acoustic waves of ultrasonic and hypersonic frequencies, and those on the effect produced by X-rays on infrared vibrations in crystals exposed to ordinary light. He once said, "I have a feeling that if the women of India take to science and interest themselves in the progress and advance of science as well, they will achieve what men have failed to do. Women have one quality, the quality of devotion. It is one of the most important passports to success in science. Let us therefore not imagine that intellect is a sole prerogative of males only in science. So rightly said. Thank you. Thank you so much.